So boys and girls, for this question, we are given you figure 6, in which we have a graph of stress against strain for a given material. And the question said the area under the line will actually represent the strain energy per unit volume of the stretch wire. So use the graph to find the strain energy per unit volume of a stretch wire if the strain of 3.5 to the power of negative 3. Sorry, it should be if the strain is 3.5 to the power of negative 3. So boys and girls, we want to determine the strain energy per unit volume, which is U over V, when our strain that produces, so 3.5 to the power of negative 3 can be written as 0.0035. So if you recall the concept we learned in lectures, the strain energy per unit volume, U over V, is actually represented by the area under the stress strain graph. Okay, and the SI unit for strain energy per unit volume will be joule per meter cube. So we are going to apply the concept to solve this question. So I want to calculate the strain energy per unit volume when the strain is 0.0035. So refer to the graph. So I draw the line. So here will be 0.0035. So I should calculate the area under the graph up to this value of strain. So the strain energy per unit volume will be equal to the area of stress strain graph. So I'm going to calculate this area of the graph. So I'm going to have half multiplied the value of strain is 0.0035 and the value of stress at that particular strain is 250 to the power of 6 Pascal or Newton per meter squared. So you may pause the video to do the calculation, then you will get the strain energy per unit volume should be 4.375 to the power of 5, and the unit should be joule per meter cube. So class, basically if you refer back to what you learned in your lectures, actually we might also calculate the strain energy per unit volume using equation half multiplied stress multiplied the strain, the value of strain O. So means that if you know the value of stress at a particular value of strain, then you can using this equation to calculate the strain energy per unit volume. So if I refer to the question, so I might also calculate the U over V by using equation half stress multiplied strain. So I'm going to read the value of stress. The value of stress when our strain is 0.0035. So if you read from the graph, the value of strain will be 250 to the power of 6 Pascal. So we put it, so substitute the value. So the stress is 250 to the power of 6 Pascal and the strain is 0.0035. So you can also get the same answer, 4.375 to the power of 5 joule per meter cube. So there are two ways for us to calculate the strain energy per unit volume. You might using the equation straight away, half multiplied the value of stress, the value of strain, or you might using concept the strain energy per unit volume is the area under the stress strain graph. But then class, distinguish betul-betul ya. Actually kita ada dua. We have strain energy, which is represented by U, and then we have strain energy per unit volume, which is U over V. So for the strain energy, it will equal to the area under force a gas elongation graph. So force a gas elongation graph within the limit of proportionality. So the area under the graph will represent strain energy. But then for strain energy per unit volume, it will be represented by the area under stress strain graph. So different thing dua benda yang berbeza baca soalan betul-betul. So if you have stress a gas strain graph, then the area under the graph should represent strain energy per unit volume. So read the question carefully, see whether you want to determine the strain energy or you want to determine the strain energy per unit volume. Whether you are given the graph F a gas along extension or you are given the graph stress over strain. So the area under the graph will represent different concepts. So read question carefully so that you're able to apply the right concept. Okay.